Good morning to everyone. I'm Monia Santini, researcher at the Foundation Euro-Mediterranean Center on Climate Change, CMCC, the acronym, and where I coordinate the Institute on Climate Resilience, whose research operates at the intersection of climate, ecosystem, and society to support short to long-term decision, planning, and investment toward climate resilient development. I welcome you to this webinar held by Edoardo Borgomeo from the University of Cambridge, who will focus on some paradoxes concerning water security. I attended in March a very interesting seminar held by Edoardo at Politecnico di Milano, and it is a pleasure he accepted to tell us more about his research activities. Before starting, I would like to say a few words about the CMCC Foundation. We are a research center whose mission is to conduct studies, carry out analysis, and develop models on the climate system and its interaction with the ecosystem and the society. The aim is covering from science to solutions, so to produce useful results to support the formulation of climate, both adaptation and mitigation policies based on scientific knowledge. In turn, stimulating the sustainable growth and environmental protection in the context of a climate resilience development. CMCC is organized as a network of thematic centers and groups which converge first into research divisions that deal with the various aspects that concern climate science, from atmosphere to ocean processes, to the interaction with the terrestrial marine ecosystem from a biophysical and biogeochemical point of view, up to risk assessment and possible solution for the environment, the economy, and the society, all in the context of climate mitigation and adaptation pathways. The research division has been recently reorganized into 3 institutes, here represented on the left, to reinforce the interdisciplinarity at CMCC in 3 main pillars, which are the prediction of the Earth system at various scales, the evaluation of impact, vulnerability, and resilience for different ecosystem sectors, up to the evaluation of interaction among the natural worlds, the physical processes with the human components through the economic and environmental sustainability components. Another peculiarity of CMCC is the Supercomputing Center, which is operational since 2008, and also computing and storage facilities were upgraded in 2022 and are currently under new upgrading and expansion to be aligned with faster and faster technological development in the world. And recently, 2 cross-cutting centers were established, respectively, a transformative hub dedicated to revolutionizing the way we understand and address climate change, bridging cutting-edge technologies with the research innovation needs for the future, and also an educational center in order to train the new generation of climate scientists. Finally, our strategic agenda for the next year is focused on 4 programs to respond to frontier issues. These deal with the integration of the planetary biogeochemical industrial carbon cycle, on predicting socioeconomic impact of climate change, on looking at the global cost as a new frontiers, and at integrating the AI, the artificial intelligence, machine learning in the modeling chain that we developed in the past. At this point, I can give the floor to Melissa Latella, who will moderate the webinar. Please, Melissa, you can go ahead.
Hi, welcome everyone. I am Melissa Latella from the Soil and Water Systems Division, SOWAS, at CMCC. I'm the moderator of this webinar today, and it's a great pleasure for me. And our speaker today will be Edoardo Borgomeo, who is Associate Professor of Water Engineering at the University of Cambridge. And before joining the University of Cambridge, Edoardo was a staff at the World Bank, working on several national and international projects on water management, and also supporting dialogue on water, and also dealing with technological and multidisciplinary issues like desalination or wastewater reuse strategies. And during his career, Edoardo spanned across different topics, from transboundary water management to climate change adaptation or stochastic hydrology. And I think that the talk of today comes out from the mix of his interest from the technological, environmental, and also policy perspective. And indeed, Edoardo will talk and will explain to us which are the current paradoxes in water management and which are the current challenges and how these paradoxes are slowing down the progress towards global water security and towards achieving the UN SDG 6. And before starting, I will just wanted to provide some technical information. Your microphones and your cameras will be switched off. And if you wanted to intervene or highlight some relevant points or ask something to Edoardo, you can just use the Q&A section or the chat, and I will take care of reading your questions to Edoardo at the end of the presentation. So thank you, and I leave the floor to Edoardo.
Thanks, Simone, and thanks, Melissa, and thanks also to the CMCC for the invite. Let me start sharing my screen. Can you just give me a thumbs up if you see it, Melissa? Yeah, great. So, yes. Thanks everyone for joining. This is a kind of a bit of an odd seminar for an academic. It's not about presenting a specific research paper or a research project. This is more of a public engagement lecture. That means that I leverage research and work that has been done by several researchers around the world, and I try to frame it and review it in a way that helps us understand why we're being so slow and why we're struggling so much with addressing global water insecurity. And so let's, again, because this is a public lecture, we're going to start with some very big ideas and issues. The first one is a picture from India. This is, as many of you will know, this is Kumbh Mela, the largest human gathering on the planet, extremely important religious event for Hinduists. They bathe at the confluence of the Yamuna and Ganges River to cleanse their sins. This is, of course, a clear example of the cultural value of water, but it's also a bit of a paradoxical situation. This is, for many of these people in the picture, perhaps the most important religious event in their lives, and it involves bathing in one of the world's most polluted rivers. So it's kind of paradoxical that, from a cultural standpoint, this event has immense value, but from a water management standpoint, what we observe is a highly polluted and highly dangerous river. Then another paradoxical situation of our global water world is the fact that millions of people still struggle to have basic access to drinking water supply and sanitation. This is a photo from South Sudan a few years ago. This is the reality for millions of people, especially in sub-Saharan Africa, but also South Asia and parts of Latin America. Access to drinking water supply and sanitation is a luxury. And in the Western world, we no longer think about the privilege of having a reliable, affordable, and safe drinking water quality and sanitation in our homes. As you know, this is not the reality for a lot of people around the world. This is paradoxical because the technologies for expanding access to drinking water supply and sanitation are there. We know how to do it, but we're still struggling to expand access at the pace required and the pace expressed in the Sustainable Development Goals framework. And then a third paradox that I want to highlight, which is more recent, and it's just an interesting reflection on the fact that these paradoxes of water are also affecting countries and places in the world which are at the forefront of technology, that places in the world that can kind of claim, within inverted commas, of course, to be the future. As you know, wildfires in the Los Angeles area were very, very damaging, a tragedy. And part of the news coverage of the event highlighted the fact that the water supply system was unable to meet the sudden peak in demand that arose from wildfires and the need for water to fight the wildfires. So in one of the most advanced places on the planet, advanced economically and in terms of technology and engineering, the water engineers are not able to foresee and confront these new extremes, these new events that we are going to have to increasingly face under climate change. This also seems to me slightly paradoxical in a place where amazing technologies are being developed, we're no longer able to know whether our civil infrastructure is up to standard and is able to confront emerging risks, emerging physical risks from the interaction of water and other environmental stressors. So we're confronted with a very, this is a very quick overview of some of the paradoxes of the world of water, which I think many of you have encountered in your professional lives. And now as academics, we like to take a step back and kind of provide frameworks to think about reality or mental models that help us map what we see in different cases into something that's more generalizable. And so here we use the concept of the paradox, a situation or a statement, as you know, that seems impossible or is difficult to understand. And in this talk, I'd like to explore with you 4 paradoxes of water. Again, this is not new to many water specialists. The objective here is not to come up with some innovation or specific academic contribution. The objective here is to try and organize what we see into something that also, in terms of public engagement, helps us explain why it is so difficult to address water-related challenges. So I identify 4 paradoxes, and I'll go through each one of them separately, but let me just state them: the paradox of value, the paradox of supply, the paradox of efficiency, and the paradox of data. So let's start with the paradox of value, which is hopefully, I think, familiar to everyone here in this webinar. Water has an infinite value, but low to no price. The paradox of value actually has a very kind of old root, and it's one of the main concepts that's explained in Economics 101. So if you're an undergrad economics student, one of the first lectures that you're gonna get is this paradox of value, which economists use to explain the concept of marginal utility. What does the paradox of value say, which was first recognized by Adam Smith, but it has also actually a longer history, including Greek philosophers? The paradox of value recognizes the fact that nothing is more useful than water, but you cannot buy anything with water. Other goods, such as diamonds, have zero use value. You don't need diamonds to live. You can survive without diamonds, but for some reason they fetch very high prices in markets. You can obtain things in exchange for a diamond. Water is abundant. Water is perceived as being abundant, and therefore it is very difficult to value. There are also other aspects that make water difficult to value, and other aspects of water that make this paradox of value so difficult to handle. For example, water is mobile, water is variable in space and time, and water also has multiple uses. You can use the same water for hydropower, and that same water can be used to irrigate a field. When you have multiple uses of the same resource, it's very difficult to establish a price or a value that's uniform across these uses. This is the paradox of value. It is extremely difficult when dealing with water to set a price that equals to the value of water, and moreover, it's very difficult to establish a price for water that actually equals the cost of delivering the service, pumping, etc. And obviously, the symptoms of, or the realization of, when we think about the paradox of value, then it makes sense. For example, when we look at leakage rates across Europe, leakage is a clear example of water being wasted and unaccounted for, and this is a clear result of this paradox of value and the challenge that we face in valuing water. Of course, there is what engineers call an economic level of leakage, meaning that at some point it's no longer economically convenient or efficient to reduce leakage in urban distribution systems. But in most countries around Europe, we're well above this economic level of leakage, which means that we're not valuing our urban water supplies in a way that reflects the value of the resource. This is the paradox of value of a place. And this is really the foundational issue of water management, that what makes the economics of water so challenging. And towards the end of the presentation, we're going to try to see some ways in which we can try and resolve this paradox of value. Let us then move on. We started with the paradox of value and the economics of water. We now move to the paradox of supply, which brings us much closer to the domain of engineers, of people that like to build things. The paradox of supply states that more water supply means more demand. The traditional way of responding to a situation of scarcity is to bring in more water supply. In the Western US, large water transfers from the Colorado River up to Nevada to quench the thirst of Las Vegas, for example, or more recently in the Gulf countries, very scarce, increasing demands from growing populations, growing economic activity, huge investments in desalination that create supply and respond to this demand. Desalination is a great option that we have amongst the range of options to address water scarcity. What happens when we invest a lot in creating new supply without signaling the cost of creating that supply? We typically incentivize overconsumption. We create a false sense of abundance that then invites people to use more water. In the Gulf countries, where we have the greatest investments in expensive desalination technologies, we also see that per capita consumption levels are some of the highest in the world, as you can see in this bar chart on the right. This is obviously a simplistic assessment, but it's kind of suggesting that if we're investing in creating new supply in a water scarce area, an unintended, undesirable outcome is actually people ending up using more water. Water is not free, it's energy. It requires energy to be desalinated. So this is an unintended and undesirable outcome, the paradox of supply. More infrastructure without the right incentives can lead to greater demand. And the paradox of supply also affects our investments in irrigation infrastructure. Irrigation, similarly to desalination, is a great technology, creates supply to achieve water security. But what have scholars observed, and this is work done by Ishad Zaveri at the World Bank and others, they have essentially observed that in areas where there were investments to irrigate water-intensive crops, rice, sugarcane, and cotton, the vulnerability of farmers to droughts increased because, again, let's take the example of Central Asia, a very dry area. We bring in lots of water through irrigation to irrigate cotton. And by doing so, we create a false sense of abundance. We incentivize further conversion of land from rain-fed to irrigated. But then when the drought comes, because the drought always comes, then you have more vulnerability to drought. And this is what economists call moral hazard, when you give people things without actually charging them for the cost of that good, or without them bearing the burden of the full risk, of the full cost of the risk, then you incentivize risk-taking behavior. If you give free water in a very dry area, you incentivize the risk-taking behavior, which is expanding agricultural land in places where there is simply not enough water. And the third example of the paradox of supply at play is the levee effect, very well known to hydrologists. The levee effect is been observed in many places around the world. If we look at this image, which is taken from a great paper published in Nature Sustainability a few years ago, you have a before and after situation. You have a town growing by a river. The response that the planner adopts to protect the town from flooding is to build an embankment or a levee in American English. What happens? You build the levee and then you incentivize the town expansion closer to the source of the hazard. In other words, you increase flood exposure. This doesn't mean that you shouldn't build levees, that we shouldn't invest in flood control. It just means that we need to be very aware of the fact that when we put a type of infrastructure in a given context, we might be incentivizing certain behavioral responses from users, in this case, increased flood exposure. And this study, which looked at the US, found that levee construction was associated with about a 60% acceleration in floodplain urban expansion, outpacing urban expansion in areas that were not protected by embankments. Essentially, this means that when we're building stuff, we're incentivizing this risk-taking behavior, this moral hazard problem, which then creates more problems because you increase the exposure to flooding and you might have to raise the levee at a higher cost to continue protecting the city. And obviously, we know that there is no zero risk in flood risk management. Therefore, the exposure has just increased, and the damage when the flood comes will be greater. So this is not to say that we don't invest in supply, in creating infrastructure. We do need to invest in creating infrastructure. At the same time, we need to invest in behavioral interventions, in demand management, in awareness raising, so that users, beneficiaries, as they're called in investment terms, are aware of the impact that these infrastructure investments have on their reality and their perception of reality. The third paradox is the paradox of efficiency, again, very well known to people that work in, especially in irrigation. It states very simply that improvements in water use efficiency do not lead to water savings. Again, if there are economists in the room, this is the Jevons paradox, in what we call Jevons paradox. And this is essentially stating that improvements in the efficiency of resource use do not lead to lower use of that resource. How does this paradox of irrigation of efficiency come about in the water sector? The classical example is again in irrigation. Why? Because irrigation is the largest water user around the world, and therefore governments have said, okay, we want to address water scarcity. Let us target the largest water user. Let us target irrigation, so that if we reduce water use in irrigation, we can then take that water and give it back to the environment, or we can take that water and give it back to the cities that are growing and need that water. So governments love supporting increases in irrigation efficiency, because this will help reduce withdrawals and will also help improve crop productivity or crop per drop. So you can grow more stuff with less water. And the person pictured here is the former Minister of Agriculture of Australia, where this kind of thinking has framed discussions around investments in irrigation for a long time. Now things are changing, but this is just an example. But then what is the result? We invest a lot in irrigation efficiency improvements, i.e. we subsidize farmers to install drip irrigation systems on their farms, with the idea of farmers growing more crop per drop, but also saving the water to reallocate that water to the environment. Unfortunately, what we observe is that water reallocation to the environment doesn't materialize. Why is this? Again, economics comes to help us, and this is work done by Dionisio Blanco Perez, who actually used to work for CMCC. And it reminds us that if you have two policy objectives, more crop per drop and reduced water withdrawals or water use for agriculture, you have two policy objectives, but you're only using one policy instrument, which is investing in drip irrigation. In economics, they dislike this thinking. The first winner of the Nobel Prize in economics told us that in order to achieve the targets set for a certain number of objectives, two objectives in this case, we need an equal number of instruments. So we cannot save water and increase crop per drop by just using drip irrigation. Why? Because farmers, when given subsidies to install drip irrigation, what do farmers do? They typically become richer, which is a good thing. They're able to grow more valuable crops because they're able to deliver the water more efficiently, for example. But then what do they do with that increased income? They might extend the irrigated area. So there is some expansion going on. And obviously, when they expand, then they need more water to irrigate that new crop area. And this happens in Rajasthan in India. Subsidies for drip irrigation improved farm incomes, but then farmers increased the irrigated area and therefore the total water that they apply. And similar observations were also made in a very well-known paper by Wild and Pulido Velasquez on the lower Rio Grande in the US. And Dionisio Blanco Perez has very usefully done a review paper that looks at this paradox of efficiency in irrigation. They looked at a number of interventions that promoted water efficient technologies, i.e. drip irrigation systems, in a number of places around the world. And what they found is that mostly these interventions led to an overall increase in water consumption. So we were able to achieve the increase in crop productivity, but we were not able to achieve the reduced water use and reallocation to the environment. The red triangles on the maps are places where this water consumption increased following investments in drip irrigation. So the conclusion from this review paper said high irrigation efficiency typically contributes to intensification of water scarcity. This is the paradox of efficiency that we need to be aware of. It doesn't mean that you don't invest in drip irrigation. It means that you invest in drip irrigation alongside other measures, as we will see. And then we look at the fourth and final paradox, the paradox of data. This is perhaps more salient. There is lots of attention and interest in artificial intelligence, including from colleagues at CMCC, which is great and very important. The paradox of data says that we want and we're doing more AI, yet we're observing a decline in monitoring trends worldwide. So the state of the art, and this is the paper published in Nature last year from people at Google and elsewhere, the state of the art says that AI-driven approaches to hydrological prediction are now best in class, or they're as performative as traditional mechanistic models. The map shows here flood risk predictions, and the areas in green are areas where the AI model outperforms GLOFASS, outperforms the traditional mechanistic model of flood risk. So the AI revolution is here and is here to stay for water management. However, we know that for AI to be effective, we need data, and we need good data. And the paradox of data is also here with us, and it's probably here to stay. What do we observe? Lots of interest in AI, yet we're not tracking the pulse of the earth as much as we should to build robust models. This is a review paper published in Nature Water, Deep Learning for Water Quality, and the review paper starts by highlighting the paradoxical situation whereby the number of gauging stations in the world is declining. You can see it in the bar chart here. This is concerning. You don't have to build AI models, you need good observational data for stream flow or for water quality, and the good observational data, or not, our ability to acquire this good observational data is declining. And the conclusion of this review paper was that data availability will probably remain the bottleneck of deep learning applications in water quality. This is very concerning. Lots of excitement around building and testing new AI models for water management. Very little attention paid to investing in the backbone or kind of the foundation for that, which is monitoring stations and gauging stations around the world, especially in places, as we know, that have been engaged for centuries, such as places in Eastern Africa or high mountain Asia. So we kind of highlighted these four paradoxes: value, supply, efficiency, and data. What do we do to solve them? What are some ways in which we can respond to these paradoxes? Again, the idea here is not to be not to give you a research paper idea. It's more to give you a big picture framing to think about how we can address some of these paradoxes. We need to repurpose and update some of our tools. Economics, we need to recognize the scarcity value of water and behavioral responses to interventions. We need to recognize the value of information. Governance, regulation, and institutions to avoid unintended consequences. And engineers need to be better capable of doing integrated planning, adaptability, circularity, and also delivering cheaper and more efficient monitoring. I'm moving towards the conclusions of the presentation. I'll just give a few examples under each of these categories to kind of ground some of these recommendations in some more in some case studies or published material. So how do we rethink the economics of water? The economics of water is a large and complex agenda. I think the first thing that we need to do as a community is to try and avoid as much as possible grand statements or simple recipes. So an example to me of a grand statement is the conclusion of the Global Commission on the Economics of Water, which has done some excellent work, for example, in highlighting the importance of green water for global hydrological stability. But some of the conclusions there in terms of the economics of water might not be so helpful. If we say value the hydrological cycle as a global common good, that is a grand statement which makes it difficult in practice to understand how we deliver a sound economic policy. And then, of course, we need to avoid simple recipes. Like Wall Street bankers often love to say, price and privatize water. it is very difficult to simply say you can price water, because as we've seen, the paradox of value says that water has different values for different uses at different moments in time and space. So what can we do to deliver a more robust and efficient economics of water, economic policy with regards to water? We need to think about quantity as well as price signals. So it's not just about getting the price right, it's also about setting other signals. For example, for farmers, that there is a cap on the amount of water that they can use. We need to think about behavioral responses to economic incentives. Again, thinking about what pricing or even metering might do to how people use water. And then we need to use a lot of strategic communication, I think, which is something that in water we haven't used enough of, but which is something which is widely used in Singapore, which, as you know, is kind of one of the best practice examples on how to manage urban water globally. In Singapore, recycled wastewater is called new water, which is clearly a great marketing idea. And similarly, around Singapore, you'll often see that they push kind of adverts or strategic communication campaigns that link the history of the country with the history of water. This is a billboard next to a bus stop that says we have come a long way in our water story. It's clearly hugely important to pair traditional economic interventions grounded in pricing with more strategic communication and marketing ideas. And I think this is a large agenda also for sustainability more broadly. Then another example is governance, and the fact that we need to identify multiple levers that we can pull when thinking about issues such as agricultural water management and addressing scarcity of water use, the scarcity of water in agriculture. Rather than just saying agricultural water management is addressed to drip irrigation and improvements in efficiency, let us list a range of options, as was done by this paper from Soumya Balasubramanian from the World Bank, a list of policy levers that we can use to address the problem of excessive water use in agriculture, and then trying to map some of these levers to different experiences around the world, and then compare and contrast results. This is what policymakers find most interesting, in my experience, is a clear presentation of the options available, of the menu of options available, and then a discussion of how these different options have been combined in different contexts to achieve certain results. So if we look at the far end of this table, we typically mention Israel is typically mentioned as an example of a country that is really capable of managing water scarcity. But people just typically say that Israel, oh, they've done lots of drip irrigation. They have lots of companies that go around the world, including in Italy, to sell drip irrigation. But then what we didn't learn, for instance, in some parts of Italy, in southern Sicily, is that actually you cannot just install drip irrigation, because in Israel, they've done a range of other things, such as quantity restrictions, prices on water and electricity, to make sure that farmers do not use excess water. So the idea of improved governance in agricultural water management is listing a range of levers to achieve multiple objectives, right? Multiple instruments are needed to achieve multiple objectives when addressing water scarcity. And then the final slide is around engineering, which is in theory my area of work. And as you'll see, this final slide is not really about engineering per se, it's more around the mental models that we use in engineering or decision trees. I'm very interested in desalination as a technology, but I think we need to improve the way in which we think about desalination as an investment and not just a technology, right? We love to talk about membranes, separation and all of that stuff, which is great, but we don't have clear ways to help decision makers, especially in developing countries, think about whether it makes sense for them to invest in desalination, when and where, etc. So this was some work that was developed at the World Bank with consultants also from Castalia. The idea here was that you try to defeat the paradox of supply, so the fact that more infrastructure will lead to more demand, and in some cases increasing burden on the financial sustainability of water utilities. The way in which you avoid that paradox of supply is to try and build simple decision trees, such as these ones, that help decision makers identify whether or not they need to invest in a certain technology, and if they have the relevant institutional regulatory frameworks to handle these new technologies. So this was an example that we had developed for the case of desalination. So I'll stop here, and thank you very much for your attention.
Thank you, Edoardo, for your presentation. It was very interesting, and I saw that the audience is starting to write some questions in the Q&A box. And I will just break the ice with a comment, maybe a short question, but it's also linked to the first one in the chat. So at the very beginning of your presentation, you talk about the cultural value of water, and I think that this should be added as another paradox. I mean, the paradox of culture, in the sense that from one side, we leverage a lot the cultural ecosystem services, and from the other side, we are not the good habits in using water, and maybe we are not educated in a proper use of water, and this deal to mismanagement. And you suggest some strategies for these, for instance, improving the communication strategies, also because I think that addressing this paradox will improve also the others. And with the communication strategies, you meant a top-down approach, I think, for instance, relating to Singapore. So I was wondering if, in your experience, these top-down approaches are more effective, but maybe promoting bottom-up synergies, or if you think that a combination is the best option.
Great, thanks, Melissa. These are great points. I like your idea of the paradox of culture, which is right. In all religions we value water. We use it for baptisms, etc. In all religions of the world, water has a clear foundational role. But then in most societies, there is very little awareness in practice or realization of this cultural value, right? So I very much agree with what you're saying. You just pay lip service to the value of water, but then in practice we don't do much. So I agree that's kind of an added paradox there. In terms of the strategic communication, yeah, I think my view, like my example, is from a top-down perspective, because I think there is a lot that can be gained there in terms, and I mean, the word strategic kind of suggests that there is a planner behind that's trying to leverage communication to achieve some water sustainability objective. But there is definitely a lot of space for bottom-up approaches. I mean, you know very well, kind of activism in the climate space gave a strong push to the climate policy agenda globally, for example. So definitely there is lots of space also for new ways of communicating and getting together about water that can help us raise awareness and defeat some of these paradoxes, including the paradox of culture. To give you an example, I'm sure people are very familiar with the concept of river walks, which are a great way of reconnecting people with rivers, and are also a bottom-up way of doing this strategic communication. River walks are, in a sense, a way of doing the economics of water that helps us understand the multiple values of water, right?
Okay, thank you. So I think we can start answering some questions in the chat, and
Sure.
if you are not able to answer to everyone, maybe I can give Edoardo the questions, and he can answer by email after the webinar. So the first question was quite related to mine. So Gopal Depnath asked if more training to farmers for some techniques is needed. And also he asked which are the latest water use efficiency technologies.
Yeah, so I think on the latest water use efficiency technologies, I'm not best placed to answer, in the sense that I wouldn't know beyond providing things that you probably already know about in terms of monitoring, Earth observation for water accounting, for example, but I'm sure you're familiar with these things. So what I'll say is that respond to the first part of your question around training. Agricultural extension services are extremely important, but kind of out of fashion in many parts of the world. But the agricultural revolution was mostly, not mostly, but partly, usually benefited from the fact that farmers were trained through agricultural extension. Especially if you look at US agriculture relied extensively on extension services and training of farmers. And therefore, I think that we need to, and this is the multiple instruments that we need to adopt to address water use efficiency. You bring in technology, but you also bring in extensive training and extension services to help farmers understand what these improved technologies help with, but also don't help with in terms of perhaps leading to excessive water consumption and extensification. So, I mean, I agree, and I think training is an often overlooked aspect in investments to improve water use efficiency, right? Which typically just consist of handling out drip irrigation systems.
Thank you. And another question is about the irrigation example. So maybe it will be useful if you can talk a little bit more about it, because Enrica Quartini is asking, in the irrigation example, if efficiency improvements led to more land being cultivated, doesn't that just mean that there was demand for more crops? So she asked if the issue is that there is a waste production or if the issues are others.
Yeah, no, I think it's a good point. I mean, if agriculture expands, it's perhaps in response to increased demand. But of course, that's a good thing for the farmer. So there is a private benefit there because the farmer expands irrigated area and makes even more money. But obviously, there's a public benefit, but there is a huge externality. There is a huge cost for society because the expansion will result in maybe a forest being cut down to give a cropland, and also to more water being used and that water not being available for downstream ecosystems. So efficiency improvement, as I said, it's good for the farmer, but it's not good for the collective. And that's the paradox of efficiency. The way in which you ensure that there is a private benefit whilst also retaining some public benefit is, for instance, by handling out drip irrigation efficiency, drip irrigation systems that allow farmers to increase crops per drop. So they do become richer, but then you also limit their water use or water consumption. You meter how much water they're using so as to avoid the expansion and the endless increase in water use.
Thank you. And we can move to another couple of questions. Andreas Papanikolaou asked, what's the biggest problem between the high water quantity used or the low quality of water that returns to water cycle?
Yeah, that's a good question. I think actually I like the question because it's kind of, if you let me, like a naive question or a very big picture question, which there is no definitive answer there, or rather the answer really depends on context and where you are. In terms of some parts of the world, for example, England, one could say that the biggest problem is water quality. Or in some parts of the world, like South Sudan, you could also say that the biggest problem is drinking water quality for South Sudan's growing cities, for example. But then clearly in other parts of the world, if we look at very dry areas, then the problem might be one of quantity and quality. So there is no global kind of response. It's both. But what I would say is that quality still receives far less attention as opposed to water quantity. And as we have observed, unfortunately, we're also monitoring water quality less, which means that we're going to be less able to predict how it's going to evolve in the future in response to climate change, land use change, and other drivers.
Okay, thank you. And then there's another technical questions about the environmental impact of desalination.
Yeah, great question. I'm not an environmental impact assessment person. There are kind of frameworks out there that desalination developers use to assess these impacts. We can obviously cite a few of these impacts. One of them is cited in the question, which is the disposal of the brine, but there are increasingly researchers who are looking to mine the brine because the brines have lots of valuable metals in them. So there is an active field of research, as I'm sure you're aware of, that really looks into metal recovery from desalination brine. So brine disposal is a problem, but also can be something valuable. It's a resource, like old waste from lots of industrial processes. A couple other environmental impacts of desalination, of course, the emissions connected to energy, especially if that energy comes from fossil fuels. Unless you have solar power desalination, then you're emitting more in the atmosphere. To have a technology that helps you to adapt to the impacts of climate change, but then you're feeding climate change by causing greater emissions for your water supply generation. Let's not forget that water is responsible for about 2% of global kind of emissions, right? So there is the emission issue, and then there is also the impact on marine biodiversity. Desalination plants have intakes, and these intakes take the water in, and when they take the water in, they can also take in a bunch of things like fish, biodiversity, invertebrates, etc. So some of these impacts can be mitigated depending on how you locate the intakes, screens, etc. But this is one environmental impact. And yeah, I think I'll stop there on environmental impacts of desalination. Yeah.
Thank you. And time is running out, but I think the next comment actually is quite relevant. Jose Albiac tells that also in the best scenario from an operational, scientific and policy point of view, there will be still an issue related to cooperation with the stakeholders. And I think that Edoardo in his experience knows a lot about it.
Yeah, no, Jose, it's a good point. It's kind of speaks to a broader issue in society around the social contract and norms, right? Whether we respect the law and regulation that surround us. Obviously, Singapore is a great example from a water perspective, but in terms of the way in which that society is run, you also know very well that it has a very distinct social contract from other places like Pakistan or Italy. So obviously, acquiring the support of stakeholders is key for enforcement, as it is the fact that the relationship between the state and society are crucial, of course, in then ensuring that some of these measures that we discussed, like enforcement of limits or measurement of water consumption, in ensuring that these can actually be kind of carried through. So I agree that the success of water policy depends a lot on these things, but one way of building stakeholder ownership is, as I said, using strategic communication. Another way is to just increasing awareness through bottom-up approaches, as Melissa was suggesting. So there are ways of essentially building that stakeholder ownership and buy-in. It just takes time. And I think the point of my presentation is actually that as water specialists, we have tended to ignore some of these aspects and we're just concentrating on the technology deployment without thinking about these broader issues which actually determine the success or failure of our water policies or interventions.
Thank you. And we can address the last question by Daiva Semeniene. He states that the socioeconomic analysis required by the Water Framework Directive and Marine Strategy Framework Directive has not played their role so far. So what do you think about this?
Yeah, so I'll be honest, I'm not familiar with the socioeconomic analysis required by the framework directives, so I'm not able to comment. I'm not able to comment on that. What I will say is that, for example, in England, people at so what I'll say is I'll just try to link this question to the point made by Jose on the effectiveness and success of water policy and regulation kind of limits, which are crucial, in my opinion, to finally improve the state of water ecosystems. You need to put limits on how much people can discharge. You need to put limits on how much water people can take out. In the UK, people have observed that following the Water Framework Directive, actually the freshwater biodiversity is kind of recovering slowly, but it is recovering. So some of these kind of command and control interventions are indeed leading to some improvements in the slow improvements in the ecosystem health. Of course, these improvements are not at the pace required, but it's just a slightly positive note with which that we can use to end the seminar, in the sense that policies can help in the long term to achieve improved outcomes for aquatic environments.
Okay, thank you, Edoardo. And I think we addressed all the questions raised in the chat. So I thank you, the audience, for the participation. I thank you for the discussion raised up with the questions. And most of all, I thank Edoardo for his presentation, his explanations. So thank you, and bye to everyone.